Hey, okay, so we're picking up where we left off. Talking about continuity. Um, and we talked about the negative base thing. Um, Logarithms are continuous as long as they actually exist. Inverses are continuous as long, over the domain of that inverse. Okay, just multiplying by constant, adding and subtracting, multiplying, dividing as long as g of c is not equal to zero. Those will all be continuous, and then compositions. All right, so then here's the type of problem that you're likely to see. All right, so it's asking you for these 3 points, find the function value, the limit from the left, the limit from the right, and the limit, and then justify uh, your findings using the continuity definition, the three-point continuity definition. All right, so here we go then. So let's see here. All right, and so when c is -3, we'll just go ahead and do this. I'm going to say, I'll just go ahead and start. C equals -3. All right, so at that, the limit coming from the left, so the limit as x approaches -3 from the left, and our function is f of x. All right, so coming from the left here, we're approaching, it appears to be -1, and that is the same as the limit approaching from the right. So x approaches -3 from the right of fx, the same. Okay. And so because of that, then the limit in general of f of x is -1. But that is not equal to, that's not equal to f of -3, because f of -3 is 2. All right. So I can say, it does say to find each of these things. So f of -3 is equal to 2. And so since those are all not the same thing, it is not continuous. F of x is not continuous. I think I'll type that. Okay, so here we go. So f of x is not continuous at x equals -3 because those two are not the same. Because the limit as x approaches -3 of f of x is not equal to f of -3. Okay. All right. So then it says to do that again for at 3. So at 3, oh boy, we've got an asymptote. All right. So let me just draw a little line here. Try not to take up as much space. All right. So we've got this is at c equals 3. The limit as x approaches 3 from the left of f of x is infinity. Okay, the limit
Oh my gosh, Dad, watch this.
is also infinity. But because of those two, we can't decide, can't determine between the two infinities. That means the limit itself does not exist. It does not exist. I'm just gonna keep going across here. And also, f of 3 does not exist. Okay, so therefore, I mean, right away, as soon as you hit one thing on the checklist that's not true, the function is not continuous at that point. All right, so let's go text box right here. So f of x is not continuous. Can't tell what I've done wrong. At x equals 3 due to a whole bunch of reasons. Due to the function not existing at that point. And a whole other host of reasons. All right, so, but those are the ones that you can go with. All right, and so then let's see, last one. All right, so then at 7. All right, so what do we have it going on at 7? All right, from the left, so when c equals 7, the limit as x approaches 7 from the left of f of x appears to be 3. And then the limit as x approaches 7 from the right of f of x appears to be about 6. All right, and that means the limit as x approaches 7 does not exist because they don't agree. However, f of 7 is the point that they gave us, and that's the one that's happening there at 3. All right, but the limit, so escape there. F of x is not continuous at x equals 7 for a bunch of reasons again. Every time. At x equals 7 for a bunch of reasons due to the limit not existing at that x value at that point. Okay, either way. Okay, it's cool. All right, so I think that'll take care of that on those. But it's not that 3-point checklist there. The limit has to exist. The function has to exist and they have to agree. And if they agree, then you are continuous at that point.